Sources: whole grain cereals, dried fruits, nuts, and leafy vegetables. Absorption. The absorption process itself appears to be quickly saturable and probably involves a low-capacity, high-affinity, active transport mechanism such as divalent mineral transporter, DMT1. Absorption occurs in small intestine. Manganese exists in two forms, namely Mn2+ and Mn3+. Absorption is enhanced by low molecular weight ligands, such as histidine and citrate. Several minerals also inhibit manganese absorption. Transport and storage. Manganese entering into the portal circulation from the gastrointestinal tract may either remain free or become bound as Mn2+ to alpha-2 macroglobulin before traversing the liver. Some manganese may remain free, Mn2+, or as Mn2+ it may be bound to albumin. It accumulates in the mitochondrial tissues, a process that may be mediated by a Ca2+ carrier. Within this they are present as hydrate Mn2+ or Mn3+. Functions. It functions both as an enzyme activator and as a constituent of metalloenzymes in the activation of enzyme-catalyzed reactions. Manganese may bind to the substrate, such as ATP, or to the enzyme directly. They include enzymes from these enzyme classes, transferases, including kinases, hydrolyses, oxidoreductases, ligases, and lyases. Transferase. Many transferases require manganese. Two examples are xylosyl transferases and glycosyl, or called galactosyl transferases. Glycosyl transferases catalyze the transfer of a sugar moiety such as galactose from uridine diphosphate, UDP. Glycosyl transferases are necessary for proteoglycan, including mucopolysaccharide synthesis. It activates prolidase, a dipeptidase with specificity for dipeptides. Prolidase is found in dermal fibroblasts and catalyzes the final step in collagen degradation. The Mn2+ may allosterically activate arginase through a pH-mediated role. Lyases, phosphoenolpyruvate carboxykinase, PEP, also activated by manganese, converts oxaloacetate to phosphoenolpyruvate and carbon dioxide. Oxidoreductase, superoxide dismutase, a manganese-dependent, Mn3+ SOD, metalloenzyme, not manganese activated, functions in a manner similar to copper and zinc-dependent superoxide dismutase to prevent lipid peroxidation by superoxide radicals. The activity of the electron transport/respiratory chain generates large amounts of superoxide radicals, necessitating substantial Mn-SOD activity. Manganese, Mn2+, one of several minerals able to scavenge free radicals, quenches peroxyl radicals. The cell ultrastructural abnormalities associated with manganese deficiency are likely caused by unchecked lipid peroxidation in the cellular membranes because of reduced Mn-SOD activity or simply by reduced availability of manganese to scavenge. Pyruvate carboxylase, which contains 4 manganese atoms, converts pyruvate to oxaloacetate. Glutamine synthetase may be a manganese metalloenzyme or may be activated by manganese or magnesium. Nutrient interaction of manganese mainly includes iron-manganese interaction. Iron in excess inhibits manganese-absorbed ion, and manganese, when ingested in amounts about 4 to 8 times recommended intake, decreases 40% iron absorption. Adequate intake: 2.3 mg for adult men, 1.8 mg for adult women, 2 mg and 2.6 mg for pregnant and lactating women. Deficiency: signs and symptoms: nausea, vomiting, dermatitis, decreased serum manganese, decreased fecal manganese excretion, increased serum calcium, phosphorus, and alkaline phosphatase, decreased growth of hair and nails, changes in hair and beard color, poor bone formation and skeletal defects, and altered carbohydrate and lipid metabolism. It occurs when men received either 0.11 mg manganese per day for 39 days or 0.35 mg manganese per day. Excretion. Manganese is excreted primarily, greater than 90%, via the bile in the feces. Excess absorbed manganese from the diet is quickly excreted by the liver into the bile to maintain homeostasis. Very little manganese is excreted in the urine. Toxicity. Manganese toxicity can occur in people with liver failure, because manganese homeostasis is maintained through bile excretion. It is characterized by manganese accumulation within the liver and other organs such as the brain.